Hey everyone, welcome back to the channel. Today we are talking about the hidden challenges behind distributed systems. Stuff that you don't usually see, but engineers have to deal with all the time. Let's uncover what makes designing distributed systems tricky yet fascinating. Let's start with communication. As I always mention, I won't be going word by word, just giving some real life examples related to the content that is being displayed. So, in a distributed system, multiple computers need to work together, but they don't have common memory or even a clock, as we discussed in our earlier video. So, how do they communicate? Through messages, just like texting between devices. But here's the issue: messages can get delayed, lost, or arrive out of order, and without a central memory or a clock, the system can't know the full global status at any moment or at any point of time. So think of it like running a group project with friends in 5 cities. Now, you don't know who has done what unless they tell you. Even then, updates may be late, right? Next significant issue, uh, the time. So, with no shared clock, how do you decide which event happened first? This is called nothing but temporal ordering. So, operating systems often schedule tasks based on when they arrive. But in distributed systems, that's not easy to track. It's like watching security camera footage from different stores without the actual timestamps. So you don't know which clip came first, and that creates the issue. Next comes naming. How do we name and locate files or resources? So the system may store directories at multiple locations for better availability. That's smart. But now we need extra storage, and syncing all the directories is really tough. So partitioning directories helps, but then finding the right partition becomes a new problem. Next, distributed systems are meant to grow, that is, nothing but scalability. But the more computers you add, the harder it gets to keep everything efficient. Like more systems is equal to more communication, which equals to more cost and complexity. Sometimes just broadcasting a message to every system becomes too heavy. Also, if each computer stores full system information, it quickly becomes too much to handle. Think of it like trying to store a copy of every file on every phone. It doesn't scale, right? And that's where the issue comes in picture. Next is another big issue: compatibility. So, all these systems might be running different operating systems or come from different vendors. There are three levels of compatibility. First is binary level. All systems use the same instruction set, simple, but it limits the variety. Second is execution level. So here we have same source code that runs anywhere after compiling. And third that comes is the protocol level, which is the most flexible one. Just follow common rules or protocols that are there, even if the machines are different. So imagine making friends from different countries. You all speak different languages, but if everyone agrees to speak English, that is the protocol here in this sense, it would naturally work. Now let's talk about synchronization. How processes coordinate when there is no shared memory. So when multiple processes need the same resource, they must access it one at a time. That's called mutual exclusion. But in distributed systems, processes can request resources in any order. which can lead to deadlocks. Deadlock is where everyone is waiting forever and nothing moves, just like sometimes Pune ka traffic. So, like four people grabbing each other's hand in a circle, and no one can let go unless someone makes a move. So, we must detect and resolve deadlocks quickly. Next is resource management. So, in distributed systems, resources are spread across machines. So, how do you manage them without confusing the user? Answer is you hide the location of resources. Let the system bring what is needed to where it is needed. This can happen in two ways. First is data migration, and another one is computation migration. So, in data migration, you move the data to the system doing the work, and in computation migration, you move the work to the system that has the data. There's a difference. For example, if a file is moved, it is handled by Distributed File System (DFS). If memory is accessed, it is managed by Distributed Shared Memory, that is DSM. For the user, it feels like magic. Files just appear where you need them. That's called network transparency. DSM gives all computers a shared virtual memory, even though no real memory is shared. The challenges here, so the first one is keeping the data consistent, and second is reducing the delays while accessing the data. Then there is, as I mentioned, the computation migration where the job itself moves. So, for example, if you need information from a remote file, your system sends a request to another, often using something called RPC, that is, Remote Procedure Call. It's like asking your friend to Google something for you because your phone is dead.
Scheduling and security. Sometimes a computer is too busy or lacks resources, so it passes the process to another system. This load sharing improves performance by using idle systems. In a single computer system, the operating system can decide which process runs when. But in a distributed system, you have got many computers, possibly in different locations. And that raises the question, how do you schedule tasks fairly across them then? So, some computers may be overloaded, others may be idle, and some might not have the right resources. So, if we don't manage this properly, some systems might be overworked while others do nothing, leading to very poor performance. So, the challenge is how do we distribute tasks smartly so that work is balanced and everything runs smoothly? Also, all this must happen transparently. The user shouldn't even notice their task was transferred somewhere else. This was all about distributed scheduling. Now, talking about the security, it's a huge concern in distributed systems. You are dealing with multiple machines, possibly in different locations, as I mentioned earlier, and they all need to talk to each other over the network. Now, how are two key security challenges? Authentication. So, how do we make sure a user or computer is really who they say they are? For example, when you log into a system, how does it confirm it's you and not someone pretending to be you? In authorization case, once you are in, how much access do you get? Can you just read files? Can you delete the stuff? That depends on your permissions. So the systems must control this smartly because giving the wrong user too much power can be dangerous. And this is how it is one of the issues in designing distributed systems.
Okay, and that's a wrap on the major issues in designing distributed systems. It's not just about connecting computers, it's about making them work together smartly, securely, and smoothly. If you enjoyed this explanation, give it a thumbs up, share it with your tech loving friends, and don't forget to subscribe for more simple breakdowns of complex tech topics. Got questions? Drop them in the comments below and I read them all. Thank you. Thanks for watching. Bye.